Aloha class, this is Gigi from Kauai Community College. This video is on the basic ideas of differential equations. So let's get started. First, we want to know what a differential equation is, right? So there's a lot of words here, but basically the differential equation involves an unknown function and its derivatives. So when we are solving a differential equation, we are looking for the unknown function as opposed to what we have previously solved for, which are numerical values, right? So the solution to a differential equation is a function y, okay? Now, there's a lot of words and a lot of new terms that you'll have to learn in this section. Um, one of which is the order. So the order of a differential equation is the highest order that appears on the derivative of the equation. Like how we have a quadratic is exponent 2, linear is exponent 1, right? So the order of the differential equation is the highest order that appear on the derivative. So for example, you can see here in blue, that's a second order differential equation because the order that involves the second derivative. Whereas the ones that are in yellow in the screen here are the first order differential equation because it involves only the first derivative. And then when we're talking about differential equations, we would have linear differential equations and we have nonlinear differential equations. Now, I'll save that for you to read over in your notes um, and, um, and digest the information. But for now, what I want to be able to do is first to understand what a solution is to a differential equation. So let's look at this example here where it's asking you to verify that y equals cosine of 4x is the solution to this DE. Now, if it is a solution, it will make the equation true. So let's consider y equals the function y equals cosine of 4x. If that is your function, then the first derivative would be negative 4 sine of 4x, and the second derivative would be negative 16 cosine of 4x. Now, if we plug that into our differential equation, we would have the second derivative, which would be negative 16 cosine of 4x, plus 16 multiplied by y, and y is cosine of 4x. Now that is definitely going to equal to 0. So the function y equals cosine of 4x give a true statement to that differential equation. So it is a solution to that differential equation. Okay, so that's what it means to be a solution. Just like if x equal to 2 is a solution, you plug 2 in for x and it gives you a true statement. Well, if y equals cosine of 4x, this function here, is the solution to a differential equation, then when you plug in the information associated with this function, it should give you a true statement. And that's what it means to be a solution, okay? Now, let's try to solve a differential equation. Now, a lot of times when we are encountering a differential equation, it will give you some initial conditions of which you can solve for a particular solution. If not, then you can only solve for what we call a general solution. And a general solution is like a family of solutions, like all of those functions that differ by a constant, you know, the plus c that we've been doing before. Okay, so for example, if you have dy equals 5 cosine of x plus 6 sine of 3x. Now we can go and integrate both sides. Okay, now the derivative on the left-hand side, when you integrate, you'll just get y. And then on the function y in terms of x, and then on the right-hand side, you will get 5 sine of x minus cosine of 3x and then divided by 3, so there's a 2 right there instead of 6, plus c. And that is what we call a general solution to this differential equation. Now, if we were given specific information about some particular point, then we can find out what c is. And that is what we call an initial value problem. For example, dy dx is equal to 10 multiplied by e to the negative x over 2. Well, if we were just going to consider that differential equation and integrate both sides, then we will have y is equal to negative 20 e to the negative x over 2, because you got to divide by 1/2. Divided by negative 1/2 means to multiply by negative 2, and that makes it negative 20, and then plus c. Okay, now that's the general solution. In order to find a particular solution, in this case, it said y of 0 is equal to 4. So when x is 0, y is 4. We plug in the information, solve for c, and c would be 24. We would say then the function y equals negative 20 e to the negative x over 2 plus 24 is the solution to the initial value problem, or we call that sometimes particular solution, because it's just one particular moment, right? Now, we then, when we are solving, need to pay attention to when, in which parameter would that function be the solution to this differential equation. That means to solve for an initial value and then to determine the domain of that solution. Okay, now when we integrate both sides, we will get the general solution, y equals t plus 3t to the 2/3 plus c. Now when we plug in t equal to 1 and y equals 4, we will solve for c, and we will see that c is actually equal to 0. So the solution to this initial value problem is y equals t plus 3 times, and to the 2/3, I wrote that as cube root of t squared because I like that. That looks a little bit nicer. Okay, now the domain to this function, if we were just talking about this particular function here, at any given moment, the domain would be all real numbers, because you can always take cube root and you can always add that to t. However, we are talking about this function as a solution to this differential equation. So when we look at that derivative, well, t cannot be 0. If t is 0, the denominator there is 0, then there would be no derivative. So right off the bat, we would say, hey, t cannot be 0 for this function here. Okay, now when that happened, and we look at the graph of y equals t plus 3 cube root of t squared, with 0 being the cutoff point, it divided up the graph into 2 segments, right? One on the left and that one on the right. Well, because this is a particular solution where the initial value has to be satisfied, we cannot take the left branch. So the right branch is where the initial value is satisfied. Therefore, we would say y equals t plus 3 cube root of t squared is the solution to this initial value problem when the domain is 0 to infinity. We're taking the branch where the initial value works. Okay, here's another. Okay, integrate both the left and the right. And if you recognize that, you would say, oh, hey, that's the derivative of cosecant with the inside derivative of 2. And there's no negative. So then we would have y is equal to negative 1/2 of cosecant of 2x plus c. With that initial value, pi over 4 for x and 0 for y, c is going to be 1/2. So then the solution, the function that is the solution to this initial value is y equals negative 1/2 cosecant of 2x plus 1/2. Now, looking at the equation, the differential equation there, cosecant is 1 over sine, cotangent is cosine over sine. Either way, sine of 2x cannot be 0, which means x cannot be 0. And x cannot be any multiple of pi over 2 because pi over 2 times the 2 there is going to be pi, and then sine of pi is going to be 0. So we don't want x to be any multiple of pi over 2. So we know that that divides up the graph of our function here, cosecant negative 1/2 cosecant of 2x plus 1/2, right? So looking at the graph of that function right there, we have, it's like a lot of many branches, right? And you have intervals between 0 to pi over 2, and then another period from pi over 2 to pi, and another period. It's just repeating. So when looking at this initial value of y of pi over 4 equal to 0, that tells you got to stay with that branch right there in the middle from 0 to pi over 2 and not any other ones, because that's when the initial value is being satisfied. So we would say y equals 1/2 cosecant of 2x plus 1/2 is the solution to this initial value problem when the domain is in between 0 to pi over 2. Meaning we only are going to take that one branch that has the initial value included in there. And that is it. That's the basic idea of differential equation. Now, in the next video, we'll deal with separable differential equations.